Hey, it's Mr. Kabbalah. This video is going to go over unit number 8, lesson number 2 on the trigonometric ratios. So if you have any questions, let me know, and hopefully this is a help, and hopefully you're doing all right. All right, so for this lesson, I already measured these. Now you might get something different, but I got BC at about 60 millimeters or 6 centimeters if you wanted to measure in centimeters. AB about 26 millimeters, which would be 2.6 centimeters, and then AC 65 millimeters, which would be 6.5 centimeters. And again, you might have slightly different numbers. They shouldn't be too far off, but in any case, now it's asking us to write these ratios. So BC over AC, so that would be 60 over 65. And I go to a calculator, 60 divided by 65 is, and what are they at nearest hundredth? So 0.92. And again, depending on what you have for your measurements, you might have something slightly different, but it should be right around 0.92. All right, AB divided by AC. AB is 26, AC is 65. So 26 divided by 65 rounded to the nearest tenth is 0.40. And then finally, we've got BC, which is 60, divided by AB, which is 26. And 60 divided by 26 is 2.31. And just one more time, you might have slightly different numbers depending on your measurements. So now it says, let's calculate, they tell us that this angle here is 67 degrees. And what we're going to do is go to our calculator and evaluate each of the following and verify that they either match or are close to the ratios you found in number 1. So hopefully they match or they're close. So if we go to our calculator, the sine of 67 is 0.92. And then notice that that number here matches this number here. All right, cosine 67 0.39. And just note that that number is pretty darn close to 0.40. And then finally, if we do tan 67, 2.36, which it's pretty close to 2.31, so not too bad. Yeah, they match pretty well. All right, given right triangle DEF shown, write down each of the following ratios do not express as decimals. So we're just going to write a fraction. All right, so the first set of 3 are using D as a reference angle. So sine of D, so this side here is the hypotenuse. It's opposite the 90-degree angle. This side here is opposite the reference angle, which is D, and so that makes this the adjacent side. So the sine of D would be the opposite over hypotenuse. So that's 9 over 15, which, let's reduce that down. If we divide each of those by 3, we get 3 over 5. All right, cosine of D would be adjacent over hypotenuse, so that would be 12 over 15, which reduces, if we divide both top and bottom by 3, we get 4/5. And then the tangent of D would be 9 over 12, which reduces to 3 over 4. All right, now for reference angle F, this one here, Basically, the hypotenuse stays the hypotenuse, but these get flip-flopped. So this is now opposite the reference angle, and this is the adjacent side. So sine of f would be opposite over hypotenuse, which is 12 over 15, which reduces to 4 over 5. Cosine of f would be 9 over 15, which reduces to 3 over 5. Excuse me. And then we have 12 over 9, opposite over adjacent, for the tangent of f. Question 4, in any right triangle, what must be true about the sum of the measures of the two acute angles? So what this is getting at is that there are 180 degrees in a triangle. 90 of that is taken up by the right angle. So that must mean that the two acute angles must be complementary, which, if you wanted to get very specific, means that they add to 90 degrees. That way, those two put together equaling 90, and then the 90-degree angle would equal 180 degrees in total. Do you notice anything about the sine and cosine of the acute angles in number 3? So let's locate the sine and cosine. So sine of D is 3 over 5, and the cosine of F is 3 over 5. And then if we look at the sine of F, it's 4 over 5, and the cosine of D is 4 over 5. So what I might say is something like this. The sine of D equals the cosine of F, and the cosine of D equals the sine of F. Something like that. Number 6, triangle MNP, angle P is a right angle. So I'm going to start by drawing a right angle, and that's going to be P. All right, so we've got a hypotenuse here. All right, it says MP is 24, NP is 10, and MN is 26. Now, another thing we know about right triangles is that the hypotenuse has to be the longest side. So, and it's also opposite the 90-degree angle. So this side has to be 26, which means that this has to be MN. Now, I don't think it's going to matter, MN. You could have those reversed, and then we can kind of backfill in the other numbers. MP is 24, and NP is 10. Now, obviously not to scale, but we do what we can. All right, so then which of the following is the value of cosine n? So n is our reference angle. For cosine, we need cosine is adjacent over hypotenuse. So the adjacent side would be 10. The hypotenuse is 26. If we reduce that, we get 5 over 13, which is choice number 1. In the following diagram of triangle QRS, QR equals 8, QS equals 17, determine the value of sine of Q. Show how you arrived at your answer. So our reference angle is Q. Now for sine, we need opposite over hypotenuse. Well, we have the hypotenuse, it's 17. But this 8 is actually the adjacent side to angle Q. So we need to find SR. And to do that, we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. We know the hypotenuse, so we're going to take the hypotenuse, square it. I'm skipping a few steps. We're going to subtract the side that we know squared, and then 17 squared minus 8 squared. I get 225. And then we have to take the square root of that, and we get the side length of 15. So our opposite side is 15, our hypotenuse is 17, and then that's it. That's all. That's 15 over 17. If you could make it a decimal, I guess, but I'd leave it 15 over 17. Number 8, they are similar triangles. EFG is similar to MNP. Cosine of E is 4 to 7, or 4 over 7. So what that tells me, E, our reference angle, cosine of E would be the adjacent over hypotenuse. So the 4 over 7 means that the adjacent side, EF, is 4, and the hypotenuse, which would be EG, is 7. 4 over 7. Now it tells us that MN, where we want to find MN, so this side here, and we're told that the hypotenuse here is 20. So what we can do is set up a proportion. So line equal sign line. We've got 4 to 7. Now the 4 corresponds to the side we want to find. I'm going to call it X. And then the 7 corresponds with the 20, the hypotenuse. And then if we cross multiply, we get 7 times X is equal to 80. And it says round to the nearest tenth, and 80 divided by 7 is 11.4. And that's the answer. Number 9, which of the following is closest to the measure of angle A? Use your calculator to help you determine the answer. So one way we could do this, so A is our reference angle. They give 4 over 16. 4 happens to be opposite angle A. 16 is adjacent. They don't tell us the hypotenuse, so the trig ratio we're going to use is tan of A is opposite over adjacent. So that's going to be 4 over 16. And 4 over 16 is 1/4, which is 0.25. Now there's other ways to do this, but what I'm going to do is I'm going to go through and test the tan of 9, the tan of 14, the tan of 36, and the tan of 42 on my calculator, and I'm going to see which of those comes closest to 0.25. So tan of 9, is that close to 0.25? Tan of, what was the next one? 14. That's actually pretty darn close. So I'm going to say it's tan of 14. So that means that angle A has to be 14 degrees, or close to it. Consider the definitions of the sine and cosine ratios. Why can the values never be greater than 1? Use a triangle as reference to help answer your question. The reason why is that the hypotenuse is always the largest. And so when you do sine and cosine, the opposite and the adjacent are over that hypotenuse. And they're always going to be smaller than that hypotenuse. So anytime you have a fraction where there's a small over a large, then you're going to get something that's less than 1. Because tangent can be opposite over adjacent, the opposite can actually be greater than the adjacent side sometimes. So that's why tangent can sometimes be more than 1. But with sine and cosine, it's opposite and adjacent over the largest side, so it can't be more than 1. It's always going to be less than 1. And I believe that's it. So hopefully this helped. Let me know if you have any questions, and hopefully we'll see you soon. Bye now.